Forget everything you know about modern construction sites. Imagine a world without electricity, chainsaws, bulldozers, or even precision measuring instruments as we know them. A world where every stone and every log was processed by hand, and every day was a test of strength and ingenuity. We are accustomed to admiring the grandeur of medieval cathedrals, castles, and bridges, their remarkable durability and architectural sophistication. But how did they build them? What superpowers did these people have if they erected such monumental structures that still stand today, sometimes surpassing many modern buildings created with the use of high technology in terms of strength and durability? Do you think this is impossible without some ancient, lost technology or alien intervention? What if I told you that the secret of their craftsmanship lies not in magic, but in ingenious simplicity, astonishing ingenuity, and a deep understanding of materials? Get ready to dive into the amazing world of medieval construction, where every tool was an extension of the craftsman's mind and will, and every builder was a true wizard, bringing the boldest architectural fantasies to life in stone and wood. Watch this video to the end, because what you learn will make you look at the history of human achievement in a new light and appreciate the incredible power of the human spirit. Subscribe to the channel so you don't miss out on new exciting stories that will change your view of the past and show you how amazing our ancestors were. Let's start with a tool that seems archaic in modern times, but in the hands of a medieval carpenter was a true marvel of engineering and craftsmanship. This is the adze. If you think that English carpenters of the 12th and 14th centuries used only crude axes to work with wood, you are overlooking the key to their remarkable precision and the durability of their wooden structures. The adze is not just a type of axe. It is a specialized tool with a blade perpendicular to the handle, similar to a hoe or a pickaxe. It was absolutely indispensable for giving logs and beams a perfectly smooth surface, chamfering, creating complex profiles, and precisely leveling large surfaces. Unlike an axe, which cuts mainly along the grain of the wood, an adze removes thin, clean shavings across the grain, achieving a level of finish unimaginable with a rough axe. An experienced carpenter could use an adze to level the surface of a log to such an extent that it looked almost sanded, creating the perfect base for subsequent, precise joints. This work required not only considerable physical strength and endurance, but also incredible coordination, a keen eye, and a deep feel for the material. The master had to understand how the wood would behave under impact in order to avoid chips and unevenness. In essence, working with an adze turned woodworking into a kind of sculpture, where each blow shaped the future beam or column. It was thanks to their mastery of the adze that the wooden structures of medieval buildings were not only surprisingly strong and able to withstand enormous loads, but also aesthetically appealing, often serving as decorative elements in the interior. Do you think that was the extent of woodworking? What if I told you that truly elegant shapes required completely different tools that you may not have even heard of? If you want to learn how medieval carpenters created smooth lines and subtle curves, watch this video to the end. To truly appreciate the skill of medieval carpenters and the role of the adze in their work, you need to understand the context. At a time when metallurgy had not yet reached modern levels and power-driven machines were a thing of the distant future, every tool was the result of careful blacksmithing and required years of training and practice to use. The adze was one of the first specialized tools for woodworking, evolving from simple stone axes in prehistoric times. By the 12th to 14th centuries, it had acquired its classic form, a wide, slightly curved blade securely fixed in a sturdy wooden handle. The angle at which the blade was attached to the handle was critically important, as it determined the effectiveness and accuracy of each stroke. There were different types of adzes designed for different tasks, from heavy-foot adzes used for rough-hewing logs on the ground to lighter-hand adzes used for fine work and finishing. Some adzes had a flat blade for leveling large surfaces. Others had a concave or convex blade for creating recesses or roundings. The process of working a log with an adze began with securing it, often on special trestles or directly on the ground. The carpenter stood over the log and struck the surface with the adze, moving along the log. With each blow, the blade cut off a thin shaving, leaving behind characteristic, slightly wavy marks, which, however, were much smoother and neater than those left by an axe. These marks, called adze marks, can still be seen on ancient wooden structures and serve as a kind of fingerprint of the medieval craftsman, evidence of his virtuosity. It is important to note that working with an adze was not only physically exhausting, but also potentially dangerous, requiring extreme concentration and control over the tool. One wrong blow could ruin expensive material, or worse, cause serious injury. Therefore, training in the use of the adze began at a young age and continued throughout the craftsman's life, perfecting his skills. Craftsmen valued the adze for its ability to read wood. An experienced carpenter could feel the direction of the grain, knots, and other features of the wood, adapting his strokes to prevent splitting or tearing. This allowed for the creation of structures with minimal waste, which was extremely important in an era when wood was a valuable and labor-intensive resource. Axes were not only used to create load-bearing beams and columns, they were used to make wooden floors, doors, window frames, and to create complex joints such as mortises and tenons, which required perfectly flat surfaces for a tight and secure fit. Without the adze, it would have been impossible to achieve the precision and fit that ensured the durability and structural integrity of medieval wooden buildings, many of which still stand today, having survived the centuries. This is a testament not only to the strength of the wood itself, but also to the unmatched skill of those who worked with it with such deep understanding and respect. It was the adze that laid the foundation for the development of more complex hand tools that appeared later, but which still relied on principles honed over centuries of working with this seemingly simple yet surprisingly versatile tool. So, we have established that the adze was indispensable for leveling flat surfaces. But how did medieval craftsmen create those elegant arches, curved beams, complex profiles, and decorative elements from wood that adorn Gothic cathedrals and castles if there were no numerically controlled machine tools? Do you think everything was angular, primitive, and lacking in refinement? What if I told you that they had tools that allowed them to work wonders with wood, giving it almost any shape? The answer lies in planes and scaffolding. These tools were true works of art in the hands of carpenters, allowing them to work with wood with unprecedented precision and artistic flair. The plane, or as it is sometimes called, a draw knife, was a long, sharp blade with two handles on either side. The craftsman would pull it toward himself or push it away, removing the thinnest layers of wood. This tool was ideal for forming smooth curves, roundings, and creating convex or concave surfaces. It allowed large curved parts, such as roof frame elements, curved window frames, or furniture parts, to be processed with remarkable symmetry and smoothness. The shirkbull is another type of plane, but with a convex, sometimes semicircular blade. It was designed for rougher work, quickly removing large amounts of material and shaping the initial form. After working with a scaffolding, the surface was left with characteristic waves which were then smoothed out with other tools, such as a plane or ordinary planes. It was these tools that allowed carpenters not only to trim wood, but also to give it complex organic shapes, which was extremely important for the aesthetics of Gothic cathedrals and castles. Without them, it would be impossible to imagine the open-work wooden structures that still amaze the imagination today. Let's take a closer look at each of these indispensable tools. The draw knife was so versatile that it could be used for a wide range of tasks, from removing bark and rough shaping to finishing and creating complex profiles. Its curved blade allowed the carpenter to control the depth of the cut by adjusting the angle and pressure. To work on convex surfaces, the craftsman could pull the draw knife toward himself, and for concave surfaces, he could push it away. Different sizes and shapes of draw knives allowed the tool to be adapted to the specific task at hand. For example, long planes with wide blades were used to work on large, curved beams, while short planes with narrow blades were used for fine work on decorative elements. Craftsmen often used planes in combination with a wooden shaving bench, shaving horse, which allowed the workpiece to be securely fixed and freed both of the carpenter's hands for working with the tool. This increased the efficiency and safety of work, especially when forming complex curved parts. Although a scrub plane is a type of plane, it differs from a traditional plane in its cambered blade. This feature allows it to quickly remove large amounts of material, leaving behind characteristic deep shavings. The purpose of the scrub plane is not to achieve a perfectly smooth surface, but to quickly and efficiently give the workpiece an approximate shape by removing excess wood. It was ideal for the initial processing of uneven logs and boards, as well as for creating rough curved shapes that were then finished with more precise tools. For example, if a curved beam was required, the carpenter would first use a shave to remove the bulk of the material and bring the workpiece closer to the desired curvature. Only then would a plane and other planes be used to achieve the necessary smoothness and accuracy. The effectiveness of the adze lay in its ability to move quickly through the material, saving the carpenter time and effort. Together, planes and adzes formed a powerful duo that allowed medieval carpenters to tackle the most complex wood-shaping tasks. These tools were key to creating roof frame elements such as rafters and trusses, which often had complex curved shapes to ensure strength and aesthetics. They were also indispensable in the manufacture of furniture, wooden sculptures, and carved decorative elements adorning churches and palaces. The ability to shape wood into virtually any form without the use of mechanized tools is a testament to the incredible skill and ingenuity of medieval craftsmen. They did not simply follow templates. They understood the properties of wood and knew how to tame it to achieve the desired shape, transforming raw material into works of art and functional architectural elements that have survived the centuries and continue to delight with their beauty and durability. Look at the majestic proportions of medieval cathedrals, their perfect symmetry, and the flawless curves of their arches and vaults. How did medieval architects and builders achieve such precision and harmony in their grandiose structures without computers, sophisticated drawing programs, or even paper blueprints as we know them today? Was everything done by eye, and did they simply rely on luck? That would be madness. But what if I told you that they used tools that were the basis of all the geometric magic of the Middle Ages, embodying complex mathematical concepts in the simplest of devices? These were marking compasses and drawing knives. The compass was not just a tool for drawing circles on paper. In medieval construction, it was a universal tool for transferring dimensions, dividing segments into equal parts, constructing angles, creating complex geometric patterns, and proportional diagrams, both on parchment and directly on stone or wood. Master masons used huge compasses to mark out stone blocks before cutting them, ensuring that the elements fit together perfectly. It was with the help of a compass that the radii of arches, the shape of vaults, and the proportions between different parts of a building were determined. A chisel is a sharp metal rod used to draw precise, thin lines directly onto the surface of stone, wood, or plaster. These lines served as an absolute guide for further processing, cutting, carving, or grinding. Each mark made with a chisel was extremely important, as the accuracy of the entire structure depended on it. It was thanks to these seemingly simple but fundamental tools that medieval craftsmen were able to bring to life the most complex architectural designs based on the principles of sacred geometry and mathematical proportions, ensuring not only the beauty, but also the structural stability of their creations. Let's dive deeper into the world of medieval marking. The compass in the hands of a medieval craftsman was more than just a tool. It was an extension of his mind, the embodiment of the universal laws of geometry. At a time when the metric system did not yet exist and units of measurement could vary from region to region, the universality of geometric principles expressed through the compass ensured remarkable accuracy. There were various types of compasses, from small, portable ones used for drawing on parchment or wax tablets, to huge ones, several meters long, designed for use on construction sites. The latter could be made of wood or metal and had sharply pointed ends capable of leaving marks on the stone or wood. They were not only used to draw circles and arcs. Compasses were used to divide lines into equal segments, construct regular polygons, and create proportional grids, which served as the basis for scaling and transferring dimensions from drawings to actual structures. The concept of sacred geometry was the cornerstone of medieval construction. It was believed that certain geometric shapes and proportions reflected divine order and harmony, and their use in architecture gave buildings not only beauty, but also spiritual significance. The compass was the main tool for implementing these principles. For example, constructing an arch of a specific radius, dividing a circle into equal sectors to create a rosette, or determining the ideal ratio between the width and height of a nave all required masterful use of a compass. Master masons and carpenters did not simply copy drawings, they understood the mathematical principles underlying them and could adapt them to the specific conditions of the construction site. The scriber was no less important. Unlike a modern pencil, which leaves a graphite mark, the scriber scratched a thin but clear line on the surface of the material. This line was permanent, did not fade, and served as a reliable guide for further processing. In stonework, scribers were used to accurately mark the locations for cutting grooves, joints, or decorative elements. On wood, they helped carpenters accurately determine the locations for cutting, sawing, or cutting joints, such as mortise and tenon joints. Various types of scribers were often used, from simple metal rods with a sharpened end to more complex tools with adjustable blades for drawing parallel lines or lines at a certain distance from the edge. The combination of a compass and a marking tool allowed medieval craftsmen to work with incredible precision and confidence. These tools were the basis for creating templates made of wood or parchment, which were then used to reproduce complex shapes and elements multiple times, ensuring uniformity and symmetry. The lack of modern measuring instruments was not an obstacle. On the contrary, it contributed to the development of a deep understanding of geometric principles and an intuitive sense of proportion among craftsmen. Every cathedral, every castle, every wooden structure of that time is a living testimony to how these seemingly simple tools, in the hands of true professionals, were transformed into a powerful means of realizing grandiose architectural designs that left an indelible mark on human history. Have you ever wondered how huge stone blocks, sometimes weighing tens of tons, were lifted to heights of tens or even hundreds of meters for the construction of majestic cathedrals and castles? If you can only imagine crowds of workers pulling ropes, then you are overlooking one of the most ingenious yet surprisingly simple inventions of medieval engineering. Was it really the work of thousands of slaves or some kind of incomprehensible magic? What if I told you that there were mechanisms that harnessed human power with remarkable efficiency, transforming the laborious process of lifting into a dangerous but mesmerizing ballet? These were wheeled cranes, often referred to as squirrel wheels or human mills. This impressive mechanism consisted of a huge wooden wheel, sometimes several meters in diameter, inside which one or more workers walked like squirrels in a wheel. Their weight and continuous movement drove a drum onto which a thick rope was wound, lifting the load. Such cranes, sometimes supplemented with a system of blocks and pulleys to increase lifting power, could lift tons of stone, massive beams, or other building materials to considerable heights, which was absolutely vital for the construction of tall towers, spires, arches, and walls. Working inside such a wheel was incredibly exhausting, requiring tremendous endurance and coordinated teamwork, and was also fraught with constant danger. Any mistake in coordination or malfunction of the mechanism could have tragic consequences. Nevertheless, it was these living engines that allowed medieval builders to literally reach for the sky, creating architectural wonders that still amaze us today with their scale and engineering genius, proving that human ingenuity can overcome any limitation. These amazing machines, known as treadwheels, were true technological marvels of their time. Their design was simple but extremely effective. A large wooden wheel, usually 4 to 6 meters in diameter, equipped with internal crossbars or steps on which workers could walk. The wheel was mounted on a horizontal axle, which was connected through a system of gears or directly to a drum onto which a lifting rope was wound. This rope, woven from hemp or flax, was incredibly strong and thick to withstand enormous loads. Special tongs, lifting tongs, or slings were attached to the end of the rope to grip the stone blocks. A whole team was required to operate the crane. In addition to the workers inside the wheel, there was an operator who coordinated their movements, monitored the lifting of the load, and gave commands. Sometimes auxiliary ropes controlled by other workers on the ground were used for precise positioning of the load. The principle of operation was based on mechanical advantage, where a small force applied over a large radius, the movement of the workers inside the wheel, was converted into a large force over a small radius, the winding of the rope onto the drum. The use of blocks and pulleys, complex systems consisting of several blocks and ropes, further increased this advantage, allowing loads to be lifted that significantly exceeded the direct physical strength of the workers. For example, with such a system, two people could lift a weight that would require dozens, if not hundreds, of people without a crane. Their appearance was a real breakthrough in construction technology, significantly increasing the speed and scale of construction. This was not only a question of efficiency, but also of safety, since mechanized lifting was less prone to accidents than manual lifting. Thus, wheeled cranes became not just an auxiliary tool, but a key factor without which it would be impossible to imagine the grandeur of Gothic cathedrals and the impregnability of medieval fortresses, which still inspire awe with their monumentality today. Imagine you are a stonemason in the 12th century. You need to lift and precisely position a huge, perfectly crafted stone block that weighs more than a dozen people. At the same time, you must not damage its perfectly smooth surface or leave any marks from the fastenings. How can this be done without modern cranes with vacuum suction cups or powerful clamps? Do you think they use some kind of magical pliers that disappeared without a trace? What if I told you that there was a brilliant but almost invisible, and therefore often overlooked tool that allowed them to do this, leaving only tiny, barely noticeable marks? These were Lewis irons, one of the most elegant engineering solutions of the Middle Ages. A Lewis iron is a special device consisting of several metal wedges, usually 3, that were inserted into a specially cut hole in the upper part of a stone block, which was conical or dovetailed in shape. It is important that this hole widened toward the top or had a complex geometry to ensure maximum wedging. When the crane or winch rope was pulled tight, the wedges spread or rotated inside the hole, wedging firmly into the stone and providing an incredibly secure grip. Once the block had been lifted to the required height and precisely positioned in the masonry, the gripper was easily removed, leaving behind only a small, almost invisible hole, which could then be concealed with mortar. This method made it possible to lift and precisely position even the most massive, finely crafted and perfectly polished stone blocks without leaving any rough marks from chains or hooks on their visible surfaces. This was critically important for the aesthetics of Gothic cathedrals, where every element had to be flawless. The invention and widespread use of Lewis's grippers demonstrate a remarkable understanding of mechanics, geometry, and a commitment to perfection in the smallest details that distinguish true craftsmanship. We tend to associate saws in the Middle Ages mainly with wood, but when you look at the huge, perfectly flat stone slabs that were used for floors, walls, or even as parts of load-bearing structures, you can't help but wonder, how were they extracted and processed without powerful diamond or disc saws? Was everything really done by hand, by chipping and chiseling, without any tools for cutting stone? That would have been extremely inefficient and labor-intensive. What if I told you that medieval stonemasons used special saws capable of cutting through entire rocks and huge stone blocks, allowing them to extract stone more efficiently than it might seem at first glance? These were razors and frigbobs, specialized stone-cutting saws designed for working with rock. A razor is essentially a very long, powerful, but relatively narrow saw that was used to cut horizontal and vertical slots directly into the rock mass in quarries. Its teeth were made of hardened steel, and sand was often used as an abrasive, which was fed into the cut along with water to reduce friction and remove rock debris. This saw made it possible to separate large, even blocks from the main rock. Once the razor had cut a sufficiently deep slot, a frigbob, a wider and more massive saw, sometimes equipped with weights, was often used to continue the cutting, using its weight to deepen the cut and ensure straightness. These saws, operated manually by several workers or with the help of simple winches and hoists, made it possible to extract and cut huge stone blocks into smaller pieces suitable for transport and further processing. It was an incredibly laborious and slow process, requiring enormous physical strength, endurance, and patience. But it was this process that provided builders with the necessary quantity of high-quality material for their grandiose projects. The existence of such specialized stone saws highlights the high level of technical thought and ingenuity of medieval builders. Look at the perfectly straight walls, ideal right angles, and strict symmetry of medieval buildings. How did medieval architects and builders achieve such geometric precision and correct proportions in their complex plans without modern laser levels, protractors, or sophisticated electronic measuring instruments? Did they simply draw lines by hand and everything was approximate? That would have been impossible for structures that had to withstand centuries and enormous loads. What if I told you that they used ancient but ingenious mathematical principles embodied in a simple but amazingly accurate tool that was the basis of all the geometric magic of the Middle Ages? It was a hanging square, sometimes called a Pythagorean square, or simply a master's square. This tool was a large wooden square, sometimes quite massive, with two unequal sides, the length of which was often in a ratio of 3:4:5. This principle, based on Pythagoras' theorem, allowed perfect right angles to be constructed with remarkable accuracy. To check a right angle, the master simply had to place the square against the surface being marked or use a string marked with knots at intervals of 3, 4, and 5 units, for example, feet or cubits. By connecting the ends of the string, they obtained a triangle, the hypotenuse of which, 5 units, automatically formed a right angle opposite it. The hanging square was used to mark foundations, wall corners, window and door openings, as well as to check the perpendicularity of various structural elements. It was the basis for the accurate planning and construction of buildings, ensuring not only their aesthetic harmony, but most importantly, their structural stability and durability. The use of such a tool demonstrates the deep understanding of geometry and mathematics that was available to medieval craftsmen and their ability to apply theoretical knowledge and practice to create monumental structures. We have already touched on the subject of chisels, but there is one special type that was absolutely indispensable for creating those legendary, incredibly durable medieval wooden frames that have stood for centuries, surviving fires, storms, and earthquakes. If you think they simply hammered iron nails into the beams to hold them together, you are missing the key to their longevity. What if I told you that their main secret was in nail-free joints that required incredible precision and endurance from the tool? These were chisels for spikes, or mortise chisels. These chisels were specially designed to cut deep, clean, and precise rectangular or trapezoidal holes, called mortises, into wooden beams and posts. These mortises were then fitted with corresponding tenons, which were cut into the ends of other wooden elements. This tenon and mortise joint was the cornerstone of medieval carpentry. It was incredibly strong and durable because the load was distributed over a large contact area of the wood rather than concentrated on a single nail. Mortise chisels differed from ordinary chisels in that they were much thicker, had a more massive neck, and a sturdy blade to withstand the strong and repeated blows of a wooden hammer, kyanka, used to hollow out these mortises. Their handles were also reinforced to prevent splitting. The use of these chisels was the basis for the creation of complex, rigid, and stable wooden frames for buildings, bridges, and roofing systems that could withstand enormous loads and serve for centuries without needing to be replaced. This is evidence of the highest level of craftsmanship and deep understanding of wood mechanics demonstrated by medieval carpenters. What could be simpler than a wedge, a piece of wood or metal sharpened on one side? It seems so basic that it's easy to underestimate it. But if you think it was just a primitive tool for rough work, you're way off about its true importance in medieval construction. What if I told you that it was wedges, these humble tools, that allowed huge stones to be split right in the quarry and create incredibly strong, unbreakable joints that held without a single nail or bolt? Wedges were a versatile and fundamental tool used for both powerful destruction and delicate creation. Wooden or metal wedges, often made from hardwoods or hardened steel, were driven into natural cracks or specially made holes in the rock. By driving several wedges in succession, enormous pressure was created, which split the rock into the required blocks. Sometimes wooden wedges were driven into holes and then doused with water. The wet wood swelled, creating enormous pressure capable of splitting even the most solid rocks. Wedges played an equally important role in woodworking. They were used to wedge the aforementioned tongue-and-groove joints or other carpentry joints, making them completely immovable and monolithic. The driven wedges expanded the tongue inside the groove, providing an incredibly tight and secure joint that only strengthened over time. Wedges were also used to precisely align and fix stone blocks in masonry, ensuring that they fit tightly together and distribute the load evenly. The simplicity of this tool concealed powerful physical principles that allowed medieval builders to perform tasks that today require complex hydraulic equipment or electric drills. Take a look at a medieval cathedral. Hundreds, if not thousands, of identical carved elements, whether column capitals, window gables, openwork window frames, or intricate decorative friezes. How could medieval craftsmen, without access to modern copying machines, 3D printers, or digital models, create so many identical, complex shapes? Do you think that each element was carved by eye and was unique, which would have made construction virtually impossible? What if I told you that they used a simple but ingenious method that allowed them to replicate complex architectural forms with remarkable precision and uniformity, which was the key to the scale of their structures? These were profile templates. Profile templates, or master profiles, were made of wood or sometimes thin metal. They were cut out, life-size profiles of the desired architectural detail. For example, the curve of an arch, the shape of a column, the outline of a decorative element, or part of a rose window. The mason or carpenter would place this template against the material being worked on, whether it was a stone block or a wooden beam, and using the appropriate tool, chisel, adze, plane, or gouge, remove the excess material until the surface took on the exact shape of the template. This made it possible to create countless identical elements, which was absolutely critical for the symmetry, harmony, and structural integrity of Gothic cathedrals and other large-scale structures. Templates were also used to regularly check the accuracy of already cut details as they were being made. This method not only significantly sped up the work, allowing different craftsmen to work on the same elements at the same time, but also guaranteed the highest quality and uniformity of all architectural elements. The use of profile templates demonstrates the medieval craftsmen's deep understanding of the principles of mass production, albeit manual, and their pursuit of perfection in every detail, which enabled them to erect such grandiose and durable buildings. We have just taken a fascinating and, I hope, quite unexpected journey into the world of English builders of the 12th to 14th centuries, debunking many long-standing myths about the dark, undeveloped, and primitive Middle Ages. As you can now see, their tools were simple only at first glance, but in the hands of true masters, they became a means of creating incredible architectural masterpieces that still amaze the imagination today. These people, without access to modern technology, powerful machinery, or complex computer calculations, built structures that still stand today, surviving centuries, natural disasters, and wars, and continuing to amaze us with their durability, functionality, and unearthly beauty. Their ingenuity, perseverance, deep understanding of materials and fundamental principles of mechanics, as well as their remarkable precision, are the true secrets of their success. Their work was not just a craft, it was a true art form, in which every hammer blow, every chisel cut, every measurement was of colossal importance and was carried out with incredible dedication. They did not strive for speed of construction, as we do today, but for absolute durability, structural reliability, and aesthetic perfection. And it is this pursuit of perfection that is the main reason why their legacy has survived to this day, remaining a testament to human genius. So, the next time you stand in front of a majestic medieval castle, an ancient church, or a grand cathedral, remember the seemingly simple tools and the incredible dedication, perseverance, and ingenuity that went into building them. These are not just stones and wood. They are living history of human genius, incredible craftsmanship, and an inexhaustible desire for greatness. If you want to continue your journey into the amazing world of history, discovering new, sometimes shocking, but always fascinating aspects of the past with us, be sure to subscribe to our channel. We have many more amazing stories in store for you that are guaranteed to change your view of the world and show you just how amazing our ancestors were. And now for the most important part, which of the tools presented surprised you the most and why? Or perhaps you know of other incredible medieval tools that we didn't mention? Share your thoughts in the comments.